When you're insulin resistant, that is, you've got metabolic syndrome, pretty much every chemical in the body is not quite right. Some are up, some are down, few are actually at physiologically normal levels. Traditionally, the focus is on the big guns, sugar, insulin, and cholesterol. In this series, we take a look at some of the other players, who they are, what they're up to, and how they're part of the state of insulin resistance. This week, we feature the nitric oxide system in endothelial cells. In someone who is insulin resistant, there is a chronic shortage of nitric oxide inside the blood vessels. Now, nitric oxide is a colorless gas made from an oxygen and nitrogen molecule joined together. It's produced by nearly every cell type. Its superpower is it's small and nimble, but it's not very stable. It only lasts a few seconds, but that's long enough to do some important chemistry, both inside the cell that made it as well as the cells in the neighborhood. Now, the nitric oxide that is AWOL in someone who is insulin resistant is the nitric oxide produced by endothelial cells. These are the cells that line the blood vessels, big ones and little ones. The endothelial cells produce nitric oxide with the help of an enzyme called endothelial nitric oxide synthetase, or eNOS for short. This nitric oxide signals to the muscle cells surrounding the blood vessels to relax. This process of relaxing is called vasodilation. It allows blood to flow through effortlessly, and this facilitates deliveries. When the nitric oxide is missing, the blood vessels are taut because vasoconstriction is occurring. This makes it hard for insulin to make deliveries, and when sugar isn't delivered, sugar levels spike, causing all sorts of new troubles. So, why is the nitric oxide not there? Well, on paper, it should be. Insulin's job is to put away the groceries, and grocery deliveries need to be made to every nook and cranny within the body. But getting to every nook and cranny takes a bit of coordination. Insulin makes the arrangements. You see, when the body is just chilling, resources are not wasted delivering huge volumes of blood to every nook and cranny. It's not necessary. The cells have all the resources they need to be happy. But when it's time to deliver the groceries, the story changes. At this point in time, all the vessels need to be open. Now, to get these vessels open, insulin enlists the help of eNOS. eNOS is always sitting on the surface of the cells that line the blood vessels. He typically just hangs out in the caveoli, attached to a very fancy comfy chair called a caveolin 1. When he gets the nod from insulin via calmodulin, he hops off the scaffold protein, hooks up with a partner, and together they grab electrons from NADPH, passes them to arginine to create nitric oxide and citrulline. The nitric oxide then diffuses through the membrane to do its thing. At the vascular smooth muscle, it acts on the metal center of the heme protein cyclic GMP, causing muscle relaxation. Now, some of the nitric oxide also drifts towards the caveolin 1, where it puffs up the pillow and invites eNOS to stop his production of nitric oxide and relax a little. eNOS doesn't need a second invitation and takes a break. The status quo returns until the next call for a puff of nitric oxide. Well, this is what should happen, but when you're insulin resistant, insulin levels are high morning, noon, and night. And this means eNOS is firing up nitric oxide production like a wild thing. Unfortunately, when eNOS doesn't get downtime, he gets a little cranky and careless. The result? Instead of pairing up with a friend, he opts to do his chemistry solo. The electrons from NADPH don't always get passed in a carefully controlled manner to arginine. Instead, they get tossed onto oxygen. creating peroxynitrate. This is a sizzling hot free radical which creates waves of destruction within the endothelial cells, leaving them unable to do their job. Blocks, breaks, and bung-ups follow, and deliveries aren't made. Now, this causes distress to the organs they're servicing. Cells around the body go hungry. They're short of oxygen and fuel, and the undelivered nutrients become problematic. Sugar, cholesterol, triglycerides, you name it, all accumulate. In addition to this, the endothelial cells undergo changes to their permeability and structure, and platelets become clutchy, etc., 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 compounding the problems further. Blocks, breaks, and bung-ups happen across the aortic tree, which can ultimately trigger a cardiovascular event. So if you're insulin resistant, you want to boost nitric oxide availability. Now, there are quite a few ways to do this. The first thing to work on is the bad body chemistry upsetting eNOS. You can give eNOS some much needed R&R by reining in insulin levels. For tips and strategies on how to do this, download our Willpower Report. It's free. Now, in addition, you can also put your eNOS on a training schedule. It turns out endothelial cells produce nitric oxide in response to stimulation by shear stress. And shear stress happens anytime you get the blood moving. A vigorous bout of exercise is a great way to charge up your nitric oxide battery. If vigorous exercise is out of the question, there are alternative options that will give you some of these benefits. One of the easiest and safest is remote ischemic preconditioning. You can also generate nitric oxide by exploiting an alternative nitric oxide generating system, the so-called nitrate, nitrite, nitric oxide pathway. This system can be triggered by diet and lifestyle. Being in the know will help you create better body chemistry and better health. Here are a few of the journal articles I've used to tell the nitric oxide story. Nitric oxide is just one of hundreds of chemicals in the body that are amiss when you're suffering from metabolic syndrome. Subscribe to our channel to learn more about some of the other players in the ups and downs of insulin resistance theories. Thank you so much for watching, and I'll see you next time.